I want to look at some more examples of convolution. We looked at this last time, this tutorial, and if we have a mask and an image, then the mask moves through the image in a raster fashion from the top left to the bottom right, and we do a multiply, add, replace the center pixel, and shift the mask on one. So if we put it on auto, it multiplies, adds, replace the center pixel, moves on, and it moves through the image like this here, getting the output values like so. So we're familiar with that. I wanted to look at what happens, page 192 in the book, where we have, say, a one-dimensional convolution. Say a 1, 1, 1 convolved with a 1, 1, 1. Or there are a few other examples which I'll leave you to try and do. But let's look at this one first. A 1, 1, 1 convolved with a 1, 1, 1. A 1, 1, 1, a mask convolved with an image 1, 1, 1. And this mask is going to move through the image and out through the other side, one place at a time, and it's going to do a multiply and add, and then replace the center pixel, and then shift on through. So as the 1, 1, 1 comes up to this, moves up to this, the 1, 1, 1 moves into this position where this 1 from the mask is above this 1 in the image. Then we do a multiply, it's 1. These are all zeros out here. So it's 1, and it replaces the center pixel, actually replaces a position there with that 1. And then the mask moves one place forward. And now we do a multiply and add. We multiply, this gives a 1, this gives a 1, this of course gives a 0, but a 1 and a 1 is 2, and it replaces this position or this position with a 2. And then the mask moves further on, shifts further on, and now we do a multiply and add. We add 1 plus 2 plus 3, and we replace pixel with 3. And then we'll move this here out the other end, so it'll be 1, 1, 1. And we'll do the multiplies, and it'll give us a 2. And then we'll move it further out, do the multiplies, it'll give us a 1. And in the end, we'll get a result 1, 2, 3, 2, 1, which is a triangular shape. That is, 2 square pulses give a triangular shape. We saw that in the Wikipedia page for analog convolution. Now, if we do the second example on this page 111 horizontally with a 111 vertically, then the 111 moves through this again. It moves so that the first one is on that one, multiplies them to give a 1, then it moves again, and now it's this one is above that one, and we get another 1, and then it moves again, and we get a further 1. Then we drop the mask down and move it through this one, getting another 1, 1, 1. We drop the mask down, move it through that one of the image, and get another 1, 1, 1. So the convolution of this one-dimensional mask and this one-dimensional image is a two-dimensional result. Or conversely, this here, this result can be separated out into 2 steps. So if we have an image and we're going to convolve it with this, another image and we convolve it with this, it's like getting that image and convolving with this, and then taking the result from that and convolving with this. This is known as a separable mask. So I want you to try the other examples there, 3, 4, and over the page 5, 6, and 7, and see if you can do those convolutions. I want to look briefly now at question 6.9, which is one of your homework problems in assignment 3. So if I pull this back and go down to the next page, this question says a 3 by 3 averaging mask. So you convolve an image with this, and then you convolve the result with another 3 by 3 averaging mask. And that's not the same as convolving our image with a 5 by 5 averaging mask, which is a 1, 1, 1, 1, 1, 5 rows of that. So to what is it equivalent then if it's not the same as a 5 by 5 averaging mask? A 3 by 3 averaging mask convolved with a 3 by 3 averaging mask. First of all, we place this, we take this and we place it on top of this, and then we're going to move it through, and then we're going to drop it down one, and then we're going to drop it down again. So in the first position, we'll have it, and this one will be on top of this one. And we'll do the multiply, add, replace, and we'll get a 1. And then this will move one position so that it's not on top of this, it's on top of this now. The black numbers will be 1, 1, 1. The red numbers here are 1 and 1. When we do the multiply and add and replace, we'll get a 2. And then we move it 1 forward so that this mask is now, the bottom line of this mask is sitting on the top line of this image, which will give us a 3. And then we'll move out the other end and we'll get 2 and a 1. And then this will shift down 1 and it will move into this. And we'll have to figure out what this term is going to be. It's going to be 2. And then we'll move it across 1 and multiply, add, replace, and you should get a 4, and do it again. You get a 6, and then a 4, and then a 2. So the second line of the result will be 2, 4, 6, 4, 2. And then this will drop down. We get a third one, and then we'll get a fourth one, and then we'll get a fifth one. The result will be a 5 by 5 matrix. And it's not 1, 1, 1, 1, 1, 5 times. It's 1, 2, 3, 2, 1, and then 2, 4, 6, 2, 4, 6, 4, 2, and then whatever, and then it repeats itself, and then it'll repeat itself. So that's what question 6.9 will be. Convolve that with that. That's the first line. I've told you what the second line is. You figure out what the third line, the fourth line, and the fifth line are.